of class 9, and my purpose here is to introduce a new chapter in mathematics that is none other than triangles. What is basically a triangle? Triangle, as the name suggests, is a three-sided figure. It has all three elements, namely the sides, vertices, and the angles. If we name this triangle to be ABC, then we have AB, BC, and AC to be its sides, angle ABC, ACB, and BAC to be its angles, and ABC to be the three vertices. So these are said to be the elements of the triangle. This chapter tends to build up a higher idea about the triangles by talking about a concept of congruence. What is congruence? Let us talk about a few figures. Let's take two circles with the same radii, and if we try overlapping them, we will see that they will actually coincide on each other. They will actually fall on one another, and we can say that those circles are congruent. Similarly, if we take two triangles and keep one on the other, and if they both overlap on each other, we can say that both the triangles are congruent. Now, how do we determine two triangles are congruent? Can we always overlap each other? Can we keep a triangle always on the other for determining whether if they are congruent? Obviously not. So, we have specific criteria for determining the congruence of triangles. And hereby, let me introduce one of the very important and the first criteria, and that is the SAS criterion. This simply means the side angled side criterion. What does this say? The SAS criterion is stated as an axiom. An axiom is a mathematical statement without a proof. On the other hand, theorems are those statements which have specific proofs in mathematics. Axioms, although they do not have proofs, they are accepted to be universal truths, and they can be used to prove several theorems. So, SAS axiom tells us that two triangles are congruent if two of its sides and the included angle of one triangle is equal to the two sides and included angle of other triangle. Let me state once again. Two triangles are congruent if two sides and the included angle of one triangle is equal to two sides and the included angle of another triangle. Let us understand this with the help of an example. Let us take two triangles, ABC and DEF. Let us consider that this side is equal to this side, which means BA is equal to CD, and this side BC is equal to EF. Now we can see that two sides are equal. Which is the included angle inside this? We find that angle ABC is the included angle between AB and BC, and angle DEF is the included angle between line segments DE and EF. So, these two included angles are also equal. Then we can say that these two triangles are congruent. If these two sides and the included angle inside them are equal to one another, then the triangles are said to be congruent. We can represent congruence using the symbol congruent to, and we can write this as triangle ABC is congruent to triangle DEF. This is the SAS criterion. Now that we have understood the criterion, let me solve a few problems related to this SAS rule. Let us consider a figure. In this question, we are given that OC is equal to OD and AO is equal to OB, and is asked to prove that triangle OBC is congruent to triangle OAB. So OAD. Oh, we are asked to prove that a triangle OBC is congruent to triangle OAD. Now how do we do this? We are given some basic information. OC equal to OD and AO is equal to OB, which means that these two sides and these two sides are equal to one another. Now we know that angle COB is vertically opposite to angle AOD and they both are equal. So let's write this down. Angle COB is equal to angle AOD since they are vertically opposite. And now we have two pairs of corresponding sides of the triangles to be equal, and also the angles, the included angle between them to be also equal. Thus, using the SAS congruence rule, we can conclude that both the triangles are congruent. Now we have another part for the same question to prove that BC is parallel to AD. So for this we can get the support of the congruence that we proved in the previous part of the question. We know that both these triangles are congruent to each other, so every element of the triangle will be equal to the other triangle as well. So we can find that this angle CBO must be equal to triangle OAD since they correspond with each other. Now if we try extending these lines, what do we see? We see that this angle is equal to this angle and they are alternate interior angles as well. Alternate interior angles. And as we studied in our chapter of lines and angles, we know that when the alternate interior angles which are formed by a transversal drawn on two parallel lines, they are always equal. Thus we can conclude that BC is parallel to AD by considering the alternate interior angles. Thus we end up solving that question. Now we have another question as well, which is that. Another question as well. And we have to show that P is equidistant to A and B, which means the same as PA is equal to PB. We must prove that PA is equal to B3. We are given some information in the question. AB is a line segment and line L is perpendicular bisector. But since we are given that this line L is perpendicular to AB, we can say that both the angles must be equal to 90 degree. And also since it is the bisector, we can find that AC must be equal to BC. These are the facts that we can understand from the question itself. So what we are asked to prove? We are asked to prove that PA is equal to PB. We have a side here which is AC, so we can write down it. AC is equal to BC since L is perpendicular bisector of AB. Now we can find that this angle is equal to this angle. That means because they both are 90 degree and this line is perpendicular to AB. So we can write angle PCA is equal to angle PCB, which is equal to 90 degree. The reason L is perpendicular to AB. This is the second thing. Now we can find another thing, which is PC is common for both the triangles. So we have to prove. We have these facts which are given in the question within the figure, and from this we can, using the SAS congruence criterion, it is possible to prove that triangle PCA is congruent to triangle PCB. Triangle PCA is congruent to triangle PCB. And since triangle PCA and PCB are equal, PA must be equal to PB. Thus, we end up with the solution of this question. This is all what we have to learn about the SAS congruence criterion. I hope the concept is crystal clear. Thank you. Let me end up with that.